Hi guys, this is a video about proving congruent parts. Proving congruent parts. Proving congruent triangles. Sorry, I was like looking at things, but proving congruent triangles. This is a video over proving congruent triangles. So first of all, corresponding parts. We talked about that in the introduction to triangles. If you didn't watch that video, go and watch that video so you know what corresponding parts are. We learned that if all 6 pairs of corresponding parts, which means corresponding sides plus the corresponding angles, if they are all congruent, then the triangles are congruent. But do we really need all 6? Do we really need to prove that all corresponding sides are congruent and all corresponding angles are congruent? We actually do not. There are theorems to help us prove triangles are congruent. So we're going to talk about some of those theorems. The first theorem we're going to talk about is side, side, side. So side, 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 which is also known as SSS. So side, side, side. So this one says if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So if I have 2 triangles and I say that all the corresponding sides are congruent, then I can state that these 2 triangles are congruent by side, side, side. The next one is side, angle, side, or SAS. So in this case, if I state that 2 sides are congruent and the angle that's within those 2 sides, that's included in those angles, it can't be an angle over here because it has to be the angle in between the 2 sides that we've proven that are congruent, then I can state that these 2 triangles are congruent by side, angle, side. The theorem says if 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, then the triangles are congruent. Another one is angle, side, angle, or ASA. So in this case, this one says if 2 angles and the included side of one triangle are congruent to that 2 angles and the included side of another, then the triangles are congruent. So if we say these 2 are congruent, that side is congruent, and then that angle, so you see it's the included side between the 2 angles, then we can state that these 2 triangles are congruent. Okay, I am going to erase this so I can fit some more. The next one is angle, angle, side. So angle, angle, side, or AAS, says that if 2 angles and a non-included side of one triangle are congruent to the corresponding angles inside of another triangle, then the triangles are congruent. So if I say these 2 angles are congruent, these 2 angles are congruent, and this side and that side, then I can say angle, angle, side, because I've proven that 2 angles and then the side there. So that would be angle, angle, side for congruency. And then one more, hypotenuse, leg. If I say if the hypotenuse and a leg of a right triangle are congruent, so we have, I didn't even write it. Hypotenuse, leg, or HL, so of a right triangle. If I say one of the legs and then the hypotenuse of a right triangle are congruent, then I can say that these 2 triangles are congruent by hypotenuse, leg. Okay, moving on, let's talk about reflexive sides. When 2 triangles overlap, there may be an additional congruent part. So for example, these 2 pictures, if you notice, they share this bottom part. And so that is the side that they already share. So it's called the reflexive property. So if I say this is A, B, C, and then I say this is D, B, C, then I can say CB is congruent to CB because of reflexive. Okay, because of reflexive. My dog might bark because somebody's out in the... Don't bark, Henry. Same with an angle, if an angle overlaps. So I'm going to try to draw this. I don't know if I'm going to be that good. See this angle? It overlaps. So I can say, if that was angle A, I can say angle A is congruent to angle A because of reflexive. So here is how you do a congruent triangle proof. First of all, you mark what is given. The second thing you do is you need to mark reflexive sides, if there's any. Reflexive sides and or angles. And then you want to choose a method of how you're going to prove that they are congruent. You have side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Okay? So, and then what you're going to do is you're going to list the parts of the triangle and see what you can prove. And then you'll fill in your reasons. And then you say, well, is there more? Is there more to do this proof? So we're going to do a 2-column proof. And then we will call it a day. So I have to draw this picture first, which might be hard to do, but okay. These triangles are supposed to be congruent, but that's M, that's 1 and 2. We said this angle is congruent to that angle. Said this one is congruent to that. Okay, so what we're given, this is a 2-column proof. So what you do is you say you have a statement and then your reason. So we are given that, first of all, we're given that angle B is congruent to angle A, just by the drawing, by the congruency marks. So that's given. The next thing we're given is AM is congruent to MB, or BM. BM, we can say BM, and that's given too. Okay, so we're already given an angle side. If we can prove that these two angles, we can prove it by angle side angle. So that's the thing. You list what you're given, and then you're like, well, I have an angle and a side already. So we know we're not going to prove it by side, 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 angle, side, angle, angle, side, hypotenuse, leg. So we have those. So we know we're not going to do it here or here because this isn't right triangles. So is there another side that we can prove? No, but we can prove angles. And we can prove that angle 1 is congruent to angle 2 because why? Vertical angles. We know that vertical angles are congruent. Okay, so that would be our reasoning. Vertical angles are congruent. And then I can state that triangle MBC is congruent to triangle MAD because of angle side angle. And then if we're trying to prove that, oh, whoops, I forgot to tell you what we're trying to prove. We're trying to prove that AD is congruent to BC. Then I can prove that AD is congruent to AC, because once we prove that those are congruent, AD is congruent to BC, then we can use corresponding parts of congruent triangles are congruent, because we've already proven that the two triangles are congruent. And that is how you do a proof. Thank you for watching. Bye.